last sample problem. Silver chromate is insoluble. It forms a brick red colored precipitate. Calculate the mass of silver chromate that forms when 50.0 milliliters of 0.100 moles per liter of silver nitrate reacts with 25.0 milliliters of 0.150 moles per liter of sodium chromate. So very similar to what we've done in the previous question. So to help you out, here is the actual equation that we're using. So let's look at the information that we have. We're trying to find the mass of the silver chromate. We've got 50.0 milliliters of silver nitrate. Okay, there's our silver nitrate. It reacts with 25.0 milliliters of 0.150 moles per liter of sodium chromate. So we need to find the moles of the two. And then once we found the moles of the two, which one are we going to use? Right? The least one, right? The limited. We're going to try to figure out our limiting reactant. So take a moment and devise your plan. What we have is we want to try to find the number of moles of our reactants. So we've got AgNO3, and we're given the volume and concentration. So we've got 0.0500 liters. Right? We've converted 50.0 milliliters into liters. We have to convert 25.0 milliliters also into liters. So we've got that many liters multiplied by its concentration, which will give me the following 0.005 moles. So we've got 0.005 moles, right, of the silver nitrate. The sodium chromate, we've got 0.0250 liters times the concentration, 0.150 moles per liter, to give us the number of moles, which is 0.00375 moles. Now, because in the following reaction, the ratio is 2 silver nitrates to 1 sodium chromate, the number of moles here in this part is based on 2 moles of silver nitrate. So to find the limiting reactant, we need to actually divide that by 2 to get a more accurate, right? So the number of moles of silver nitrate is 0.0025 moles, and we should have 0 because we want 3 significant digits, right? So we know that is the limiting reactant, right? So that the silver nitrate is the limiting reactant. Now, that's not the number we're going to use though for the next step, right? We're still using the first one because that's really the number of moles. We're trying to find the limiting reactant because otherwise we'd be using that value for the next part. So, what is the ratio of, well, we've got to actually come out with our table, right? We've got our table, right? Moles and molecules, right? We're going to go through the bell if the bell kind of goes off because I don't want to leave this. So we're trying to find the mass of the silver chromate. That's what we're trying to find. So that is our unknown, Ag2CrO4, right? That is what we're trying to find. And our given is our limiting reactant, AgNO3, which has the number of moles, which is 0.005 moles. What are the units that we're using here? The ratio. What was the ratio here? So we've got silver chromate, which is 1. The silver nitrate, 2. So we're going to bring the 0.005, multiply it by 2, divide it by 2. Yeah, when we bring it, right? Because 0.05, right? We're going to bring this over. Right? We've got x over 0.005 equals 1 over 2. Yeah, so x is 0.00250 moles. So what are we trying to find? The molar mass, right? So we're trying to find the molar mass. So what we're going to do is we're going to take that 0.00250 moles. We're going to multiply it by the molar mass of the silver chromate, which is 331.7 grams per mole. All right, moles cancel out. The mass that we have is 0.829 grams. So, question asked, calculate the mass of the silver chromate that forms 0.829 grams. So remember, don't forget that step, right? That was only to help us find the limiting reactant. But we didn't use that value, because in reality, that's how much we were going to use.